Okay, so here are the solutions to the week 3 quiz. I just went through and did a preview of the quiz so that I could get the question statements, and then I have my own random variables. So I'm going to work it with my variables, but kind of talk you through the process. And I have this for week 4 and week 5 quizzes as well. So you can print off the document, maybe try working it yourself, and then go through the video. So enter for the following bar with a diameter, 2.6 inches. Determine the normal stress. So I want to know what the normal stress, which I know normal stress is P over A, for segment CD. Okay. So if I want for segment CD, then I have to determine what is the internal normal stress for C to D. So I have 6P and I have 4P, and I'm going to sum my forces in the x direction equals 0, and I have negative FCD minus 4P plus 6P equals 0. Bring this over, so I have FCD equals 2P equals 2 times 184.2. 2 times 184.2. And I get that the internal force of CD is 368.4. And it's positive, so it's in tension, and my units are in kips. Okay? And stress is that force in CD over area of CD. So I have 368.4 kips divided by pi over 4. 2.6, that's my diameter, inches squared. So I have kip per inch squared. So I have pi as a number, 4 divided by 2.6 times 2.6 times. Divide that out, and I get a stress of 69.388 KSI. So it wants me to answer to a whole number in KSI. So stress is 69 KSI. Okay. For the following bar, determine the magnitude of the largest internal force. Okay, so magnitude is just a positive value of the largest internal. So what I need to do is find the internal for each segment. So if I have 2P here, I'm going to assume positive. I can see visually that that's internal of 2P. So I have 2P, 6P, I'm assuming in tension, and I can see by visual this actually has to be going in compression by amount of 4P. Cut here. And I can see, okay, if I assume it going this way in tension, I have 2 plus 4 is 6. I have 6 going that way, so I actually have an internal of 0. And then I need to look down here from A to B. So I have 2 plus 4 is 6, 0. So I have 3 pushing, so this has to be 3 in compression. So the largest magnitude for 2 and 3 is 4 times 128.12. 128.12, and I get 512.48 kips, and I want to enter it as a whole number, so 512 kips. Okay, determine the length of glue, the lapse. Okay, I need the length for the epoxy. So when I'm looking at this and I'm pulling, let me find my red pin. When I am pulling this direction P, if I look right underneath here, okay, if I take it apart, if I'm pulling P here, then I'm resisting shear. I can look at this big piece, which is 2P. That means I'm resisting 2P. Whoops. I'm resisting a shear on the top and a shear on the bottom. Okay, so if this is 2P, shear, shear, and the reason it went from a P to a V is it's going from normal force to shear force. And then I can look at the bottom again. P, which means my internal shear, is a V. Okay, so it doesn't matter which free body diagram I want to look at. They all are telling me I have this shear force V equal to P. So determine the length. So when I look at the glue is, okay, okay, the length, and then if I look at where it's actually glued, it's going to be this area that it's glued. It doesn't matter the thickness. Okay, we're gluing between this area here, so it's going to be this direction and this direction. So determine the length for the epoxy connection to the hundredths if the allowable shear stress is 0.67. So shear stress equals V over A. 0.67 KSI equals V over, okay, length, that's what I'm trying to find. Quit chewing on the chair. Okay, length is what I'm trying to find, and this is 9 times 9.86. That gives me that dimension back. So if I multiply this out, I have 0.67, and I'm told that P is 87.2. So I know that my shear has to be 87.2. So we're going to start that over. So I have 87.2 divided by 0.67 divided by 9 divided by 0.86. And I get that the length then has to be 16.815 inches. And determine the length to the hundredth. So my answer is 16.82 inches. Remember, it's the area of contact. That's the area of contact. So it doesn't matter how thick this is. Okay, that thickness would matter if I was looking at the stress over area than normal. So if I'm looking at, we're going to recap. If I'm looking at where I'm having that shear resistance of the glue, here's the shear that's acting on that glue. The area has to be the length times the width back into the page. If I were looking at yielding of this piece, like I'm making it longer, then I would have to look at this area, which I would have thickness width into the page. Okay. Determine the maximum allowed force P. So now we're going backwards. That can be applied to the board if each nail has a diameter. So area is pi over 4, 0.012 meters squared. And I have 1, 2, 3, 4. So my area is times 4. And I am in single shear, so I just leave it like that. And if I'm looking at shear over the nail, shear equals V over A. And I have to recognize that this P is equal to the shear force being resisted by those nails. So shear equals P. I have a 67.4 times 10 to the 6th pascals, which is a Newton per meter squared, equals V over pi over 4.012 squared times 4, because I have 4 nails. 67.4 e to the 6th. Pi is a number, 4 divided by 0.012 times, 0.012 times, multiply, and I get shear of 7622.76, and that's in newtons because I worked with pascals. So if my shear is this value, I have to recognize that the shear force being resisted is equal to that normal force being applied, but I want it in kilonewtons. 1, 2, 3. So it would be 7.622 kilonewtons, and if I want it as a whole number, it's just going to be 8 kilonewtons. Determine the minimum diameter needed for ED. Where is ED? For ED, to 3 places to the right of the decimal, given force, okay, 1913.3 pounds. My length is, I must have put the wrong picture on here. That's going to be my guess, and the allowable stress is 17.4. So stress is 17.4 KSI, and I have to recognize stress is P over A. Okay? That is not this force that's given. That is the actual force that's on here. But if I want to determine ED, which it should have been AC. Because, yeah, it should have been AC. So let's just pretend it's AC, and I need to go back and work on this problem. Then I have method of joints, And if I have 1913.3 pulling down, and I have method of joints, then I have the force in member okay, this is frustrating. It's running out of lead, but it's not going out anymore. Okay, so I have the force in member AB, and I have the force in member AC. And this is a 3-to-4 ratio. So if I sum forces in the y direction, I'm going to get negative 1913.3 minus 4/5 FAC equals 0. So FAC equals negative 1913.3 times 5 over 4. Because it's the hypotenuse, it will get bigger. And I have 1913.3 times 5 divided by 4. I get the internal force of AC is 2391.625. It's negative, it's in compression. With the allowable stress I gave you, it didn't signify whether it was compression or tension, so I'm just going to assume it's the same either way. So stress is internal force of AC, so I have 17.4 KSI equals, and the units on that are pounds, so I have to go 1, 2, 3. So I have 2.391 kips pi over 4 d squared. So I can calculate d, and come over, so 2.391, 17.4 divided by, pi as a number, 4 divided by, square root it, and I get 0.418 inches. Kips, those go away. And then it says the minimum bar size would be 0.418 and 3 places. So this would be my answer. That would be the minimum. Honestly, I can't go into Lowe's and order that. So I might say, like, if I had to order it, I would say like 0.5 inches, because that would be a more realistic actual size you can buy. So I'll try to go back and figure out where this problem came from and fix it. But that's how you set it up.